Hello everyone, my name is Kevin the Avidjan, and today I'll be explaining to you guys a little bit about my linear regression project. For the last 2 weeks, I've been looking into the applications of AI with climate change, and I found out that we could use deep learning and machine learning to predict weather phenomenon like El Nino, and also optimize the power grid to make it more efficient. And also, there are many more applications. But for this project, I decided to start off with a linear regression project. And the aim of this project was to show how global temperatures are steadily increasing over the last 3 centuries. And with that, with the machine learning, we can predict the temperature in the future. So to get started with my code, I imported a file from the Kaggle dataset. And the dataset I used is called the Earth surface temperature data. So I can link it in the description below and you can use it for your own projects. And for this project, I use a specific file of that dataset called global temperatures. And this is the most comprehensive file and will give me the best results for the project. So here are the libraries I imported: NumPy, Pandas, Matplotlib. I like to point out the first three. NumPy is used for the linear algebra of machine learning. Pandas helps me to read the data, and Matplotlib helps us to visualize our data through graphs. So right here, with using pandas, I'm able to visualize the data in the form of a table and with the categories, so you can see the years in all the categories. But for this project, I only need two categories: an input category and an output category, X and Y. And the specific one I needed to use is the land and ocean average temperature right here. This is the combined temperature of both land and ocean, and that also is a comprehensive um, statistic. And I think that makes my prediction much more feasible and accurate. So the code right here, this section of code actually extracts the two categories I need: the year and the land and ocean average temperatures. And what also, if you notice that the years right here are all include the month and date, but we only need the year. So with this code, we did that, and also we are able to create a line chart, a line graph that shows the trend of how temperatures are increasing over time. So you can see over here the average global temperature movement from 1750 to 2015, which are the years provided in the dataset. So now here's the machine learning part. So I imported the scikit-learn library at the start, and I need to use the train test split one and the linear regression. So for train test split, I'll use 80% of my data to train the model and 20% to test. Training is the most important part. It ensures that the actual model is accurate. And you can see right here for the training set, most of the data is scattered around, and there's a clear trend as you see, and it fits the linear regression, like the linear equation y equals mx plus b. So using a linear regression is very useful for the project. And here's the test set. So this is only 20% of the data. So we can see also it fits the trend line. And this particular set of data, the test set, is actually used to predict the actual temperatures for my model. And with that said, the last section of code is the actual prediction part. So I could input any year, and it's going to output a specific temperature with the data we've already accumulated. So for this project, I wanted to predict the temperature in 2125, 100 years from now. And if I run the code, it says the predicted temperature is 16.24 degrees Celsius. So let's compare that with 2025. And we see that the temperature is 15.71 Celsius. So we see that the increase in temperature is not that high. But with the context of climate change, a small increase in temperature is very substantial. It can impact our ecosystems. It'll contribute to the melting of glaciers in the Arctic. All of these things have huge consequences, even with small increase in temperature. And with that, I've concluded my explanation. So if you want, you can check out my code in the YouTube description. And with that, thank you for listening.